The last time an object like this came toward the sun, it spelled the end of an entire era, a deadly turn, and the dinosaurs were gone. But this time, the threat is even bigger, 4 times bigger. A new visitor from the depths of space is racing through our solar system. Designated 3IATL, this object isn't just massive, it's fast, unpredictable, and carries a disturbing sense of familiarity. When world-renowned physicist Michio Kaku saw the early data, his reaction was unexpected. He was brought to tears. Why? Because he recognized the pattern. He's seen this kind of story before, but this time, it's unfolding with humanity watching. And if this object changes course, Earth could be in its path. This isn't the script of a science fiction movie. It's happening right now. 60-6 million years ago, the sky delivered fire. A rock only 10 kilometers wide crashed into Earth, with such force that it ignited global wildfires, blocked sunlight, and plunged the planet into a long extinction-level winter. The dinosaurs never stood a chance. That asteroid had first approached the sun. It curved inward just like many other space objects, until it veered off course and struck Earth. Now, scientists are seeing something that echoes that event. July 1st, telescopes picked up a new object, massive, fast, coming from deep space. It's called 3IATL, and unlike that 10-kilometer-wide rock, this one is nearly 20 kilometers across, twice as wide and 4 times the volume. When Michio Kaku reviewed the initial data, the emotion on his face was clear. He broke into tears. He understood what such objects could do when they take a wrong turn. 3IATL is moving at over 150,000 miles per hour. It's not looping around the sun like most objects within our solar system, slicing through space in an almost perfectly straight trajectory. That fact alone tells scientists something profound. This object isn't from here. It's interstellar, like Oumuamua or Borisov before it. But unlike those, this one is bigger, much bigger, far more energetic, and just like the ancient killer asteroid, this one is also coming from the direction of the sun. In an emotional interview, Kaku warned that we may be witnessing a cosmic echo, K-pattern playing out again, only this time we have the means to see it. He called it a test. For our generation, as 3IATL approaches the sun, just like that fatal object millions of years ago, everyone is asking the same chilling question: will it change course? Kaku doesn't believe this is just a comet. There's something strange about how it moves. Not only is it fast, blisteringly fast, but it's coming from a direction few interstellar objects are ever observed: the dense, chaotic heart of our galaxy. As a physicist who's spent his life making space comprehensible to the public, Michio Kaku says this object stands apart. It's not just a comet or a rock, he said. It's a riddle and maybe a warning. The typical comets tumble, spin off axis, and shed dust in irregular patterns. But 3IATL is acting like a guided missile. Its trajectory is clean and unwavering. The gases escaping from its surface, what scientists call outgassing, don't match the usual chaotic, dusty bursts of other comets. This one releases gas in a directional, rhythmic way. Natural comets behave like messy ice balls, Kaku explained. This one feels clean, calculated. Something about it just doesn't fit. Later this year, the object will pass behind the sun. During that critical window, we won't be able to track it. For several weeks, Earth-based telescopes will be blind. If 3IATL alters its path during that time, we might not realize it until it's too late. That's why Kaku is so concerned. He recalls how Oumuamua changed speed without any visible cause. Some scientists even speculated it might have been artificial. But compared to 3IATL, Oumuamua looks like a speck of dust. Whatever this is, Kaku says, it's bigger, faster, and it's not here by accident. Whether natural or something more, its movement is purposeful. That alone changes everything. If this were just a comet, Kaku said quietly, I wouldn't be crying. That sentence shook the room. It's not from fear. It's from knowing what others don't. And this time, he says the stakes are cosmic at first. 3. IATL appears to be on a safe trajectory. It's projected to pass around 167 million miles from Earth in December. That might sound comfortably distant, but as Kaku explained, the danger isn't in where it's going, it's in how it gets there. As it approaches the sun, it's already heating up, and when comets heat up, they release gas-fast, forceful jets that act like mini rockets. This process, known as outgassing, can nudge a comet slightly off course. For most comets, those nudges are tiny. But 3IATL is not most comets. It's nearly 20 kilometers wide and traveling at 68 kilometers per second. That's over 150,000 miles per hour. Even the slightest push from escaping gases or solar radiation could cause a significant shift. Kaku described this risk with a chilling calm. The margin of error is razor thin. It wouldn't take much for a course change to put Earth in the danger zone. The asteroid that hit Earth millions of years ago followed a similar path, drawn inward toward the sun, then suddenly pulled into Earth's orbit. Initially it wasn't even headed for our planet, but it turned. And that single curve altered the fate of the world. That's what scientists fear could happen again. Because right now, 3IATL is too far for us to model its behavior precisely. Some simulations show harmless trajectories. Others show deviations that could send it veering millions of miles off course. Soon, it will slip behind the sun. That critical window known as solar conjunction will be in the dark. Literally. Telescopes and radar will be unable to detect it. That silence, that absence of data, could be the most dangerous moment of all. We will be flying blind, Kaku has another reason for his emotional response. What if 3IATL isn't alone? In just a few years, we've gone from seeing 0 interstellar visitors to spotting 3. That sudden uptick is staggering. What changed? Were these objects always passing unnoticed? Or have they just started to appear? Kaku wonders if this is part of something larger, a pattern. He compares it to seeing one raindrop before a storm. You don't worry about one. You worry when they keep coming. Now astronomers are digging through old data, hunting for traces of other fast-moving anomalies. And some are finding them faint blips, lights that moved too fast or too straight before disappearing. What if 3IATL is only the first visible part of a larger swarm? A network of silent travelers drifting through the galaxy. Or worse, what? If it's not random at all, what if it's a scout? Kaku is careful not to make sensational claims. But he's clear. The idea that this is a one-off event doesn't feel right. Whispered conversations are happening now in observatories across the globe. Are these relics of shattered planetary systems? Or messages? If 3IATL moves erratically or if another follows in its path, it could change everything we know about our place in the universe. Because this isn't just about rocks. It's about movement, intention, and perhaps observation. As the object closes in on the sun, Michio Kaku's voice has grown more urgent. In a recent interview, his voice cracked. This is not a time for silence, he said. It's a time for clarity. It's calling on space agencies to act to begin full spectrum tracking. Not just for science, but for planetary defense. Because if 3IATL shifts even slightly and heads for Earth, we won't be able to stop it. NASA's DART mission showed we can redirect small, slow-moving asteroids. But this, it's faster, bigger, and not bound to our solar system. It's not something we can deflect. It's something we can only watch. Kaku isn't urging panic. He's urging preparation. He says his tears came not just from fear, but from what this object symbolizes, a cosmic reminder. We live on a fragile planet, drifting through a shooting gallery of cosmic debris, and we're just beginning to understand the rules of the game, he said. We're smart enough to build the telescopes. Now we must be wise enough to act on what they show us. To Kaku, this isn't just about 3IATL, it's about what comes. Next, will we forget? Or will we finally take threats from the sky seriously? Because if this object turns, fragments, or slows, we'll know one thing for certain: we were warned. And this time, we were watching. There's one moment scientists fear most. Early December. That's when 3IATL will pass directly behind the sun from Earth's perspective. During this time, our instruments will be blind. The sun will block all visual and radar tracking. We call this period solar conjunction. Usually it's a brief inconvenience, but not this time. Not when the object is racing at over 150,000 miles per hour and could change direction unpredictably. Kaku calls it the cosmic blink. A few weeks when humanity won't see what's coming. If the object shifts course during that period, we might not realize it until it's already too close. Let's imagine a fast car heading toward an intersection, Kaku explains. Now imagine you lose the video feed just before it reaches the turn. When the feed comes back, it could be in a completely different lane. If 3IATL veers toward Earth while it's hidden behind the sun, our response time could shrink to days or hours. This isn't a thriller script. It's real orbital mechanics. And what happens after that silent window might determine if this story ends with relief or with disaster. If this were a movie, something spectacular would happen. The object would slow, transform, send a signal, or reveal a hidden ship. But this isn't fiction, and that's what makes it all the more unsettling. 3IATL moves mostly like a natural object, but some aspects defy explanation.